Alright, let's hurry it up. Y'all are late.
No, we're not.
It is dismissed. Alright, so get to work. Push hard, push hard. Alright. Got your hand up. Let's go.
She might be with the baby right there.
Oh, okay. Okay, go down like that. You went down.
Alright. Let's sit down, get to work. What the hell is wrong? Alright, eyes up here, y'all. Pencils down. Doom down time is over. I know we're all very sad that this is me talk now. But we're going to do a bit of review before we move on to the lesson. That first one, a little tricky. Lead for nitride. I saw a lot of y'all putting lead and then like a subscript 4. Let me show you what this is. Okay, so it's lead 4. What I've seen a lot of is PB 4 and something. But that is not correct. What the 4 is the charge on lead, not the number of leads that there are. It's the charge of lead. So what this is actually saying is that PB has a 4 plus charge, and the nitrogen has a 3 minus charge, because that's just what nitrogen is, but it's the nitride, right? So to actually get the formula for this one, what would we have to do? What'd you know? Crisscross. So you take the 3 minus, you put it there, you put it the 4 plus, you put it there, and you end up with PB 3 and 4. Does that make sense?
Yes, I understand.
So, again, the Roman numeral is not the number of atoms you have with that, it's the charge. And you're never going to see the Roman numeral on an anion. It's always going to be on a cation. Specifically, transition and base metals have these Roman numerals. We will go over why that is a little more later. Cool. So these other ones, I feel pretty confident that since you guys now know what this one is, you guys can do. Oh, I do want to tackle one thing: calcium oxide. Calcium oxide has a 2 plus charge on the calcium and a 2 minus charge on the oxygen. Would we still crisscross these?
No.
Dante,
No.
what would we do?
They would cancel out.
They would cancel out. So instead of having Ca2O2, you just have CaO. Because the goal is to have an overall neutral charge in your ionic compound. So you don't need to have 2 of each of them. We're just looking for the smallest whole number ratio. You can think about it like fractions. You have like 2 over 4. You simplify 2/4 to 1/2, right? 1 over 2. It's a very similar principle with balancing ionic compounds. Again, this is for ionic compounds, and we're talking about the nomenclature of ionic compounds today, because honestly, it's kind of a struggle for all of us. So, go and flip the page. You should find a page that looks like this. It's got a pseudo-periodic table on it. Yeah, it's not a full periodic table. It's like very much broken down to the most important parts of that we're trying to get to today, which is just like the S block, transition metals, and the P block. Very minimalistic. It doesn't show all the elements, but just the ones that we're going to be focusing on today. So, take a real quick look at that. I need a volunteer to read the top little portion of the Y for me. Daniel.
When working in chemistry is often related to write a chemical assembly. For example, we might write down a substance table so as NaCl. talking about chemistry, they type of say NaCl. When you want to refer to a substance also in formal writing, you should use the name of the compound rather than the sequence. Therefore, you need to
Right, exactly. So this is never going away. We're going to be naming compounds as long as we're in chemistry. I know in some other subjects you kind of learn something for a little bit and you're like, all right, I'm done with that. And took a test, it's out of my hands. With chemistry, especially nomenclature and charges, you're going to be working with these throughout the entire year. You take AP Chem into AP Chem in college when you take chemistry. Never goes away. So that's why we're learning to name elements now. So when you like pick up a bottle and it says sodium chloride, you know exactly what that is. So we're going to move on to 1A. Would like a volunteer to read the 1 and the A part for me, please? Sean.
Wait, like based on information in model?
Yeah.
Based on information in model 1, identify 3 elements that form only one
One cation. So looking at all the elements in our abbreviated periodic table, someone name one element. Dante. Potassium. And I need one more. Kyle. Sodium. And Louis. I need you to name a element that forms only one cation.
One cation, silver.
Silver. And then let's do 3. Let's go for one more. Chrisla. You don't know? Alright, let's look at the periodic table thing here. Which of these forms a cation? And only one cation. Give me any of them. Come on, Priscilla. Say again, please. Rubidium. Yes. Okay. Alright, now we're moving on to part B. Identify 3 elements that form only one anion. As a reminder, an anion is an ion with a negative charge. Rihanna. Fluorine. Janae. Oxygen. And sulfur. I'll take sulfur. And iodine. Alright.
Wait, I was saying that word only one anion, but they have 2 at the top.
Oh, okay. Alright, that's a little misconception we have going there. So, what it means by one anion or more than one anion, if you look at the transition metals there in the middle, you have Fe2 plus and Fe3 plus. Those are 2 different cations. Whereas fluorine, oxygen has a 2 minus, that's only one type of anion. If there was like O2 minus and like an O minus, then that'd be 2 different possible anions.
So it's just that they had a year where the ozone was frequent.
I'm not sure I quite understand the question. Yes, okay.
So that means nitrogen would be more too?
Yes, nitrogen would also be an element that forms only one anion. Yeah. So yeah, it's not about the number, it's the number of them. So having just said that, can I get some people to identify 3 elements that form more than one cation? Yes. Pb, which is lead, which comes from plumbum, if you want to remember that. Plumbum, Latin. Plumber comes from plumbum because the Roman aqueducts and sewage used to be made of lead, which is why they all got lead poisoning and died. So yeah, you'll always remember PP, lead, plumbum.
PP.
Yeah.
Oh.
gonna say, iron.
Iron. And one more. No? Okay. Okay. Kyle. Mercury. Hg. That's right. All right. So I mentioned this like a second ago, but in what region of the periodic table are these multiple ion elements usually located? Transition metals. Mostly in the transition metals. Because they transition to different ions. You also find a couple of these in the base metals / other metals. Like down here we have tin and lead. But for the most part, you're going to find these ones in the transition metals. Cool. Alright. I need a reader for number 2. Gianna, please read for class.
Consider the ions of potassium and sulfur. Write chemical formulas for all possible ionic compounds involving these ions using simple ratios of potassium and sulfur. Keep in mind that the sum of the charges in an ionic compound must equal 0.
Alright. So let's start off. How are we going to do this? Can someone tell me how we're going to start?
So,
I want to who was that? I see some hands. Who can tell me how to start? Alright, so how we're going to start is, we know that potassium has a +1 charge. We have potassium. And what's the charge on sulfur? 2 minus. Does this balance out? No. What do we have to do? Did you? Add another potassium. So now we have 2 potassiums and a sulfur, and that's going to give us K2S. So if we wanted to write this another way, could we do that? Let's say we doubled the number of everything. So we ended up with K plus, K plus, K plus, K plus, and S2 minus, S2 minus. And we had K4, S2. Yeah, you should all look confused and disgusted right now. The ratio. Oh yes. Sorry.
thank you, sir.
The ratio remains the same. So for this one, we have K2. There's 2 Ks and 1 S. And as I said earlier, K4, S2 is also a ratio of 2 potassiums to 1 sulfur. So no matter what you do to this, the ratio between the elements is going to be the same. And this goes back to what I was talking about with calcium, calcium oxide, where they had the 2s. The ratio is 1 to 1. If you have 2 and 2, the ratio is still 1 to 1 because you simplify it. All right. Flip the page, y'all. So, let's look at the top one. Consider the ions of iron and sulfur. Consider the ions of iron and sulfur. Write chemical formulas for all possible ionic compounds involving these ions, using the simplest ratios of iron and sulfur. Keep in mind that the sum of the charges in an ionic compound must equal 0. Let me give you all 1 minute. Work with your table partner and figure out one of these possible ratios. So iron has 2 different possible cations, so just choose one of those and write down the compound for that, the ionic compound. Work with your partner, I can hear some talking.
Yeah.
When I write it, it'll be FE2 or before. Because it gets
That. Sulfide, sorry. Yeah. Okay. Y'all need another minute? See, okay. Cool. So, everyone back up here, please. Michaela, could you please share what you did for the class?
I did, I wrote down FE, 2 plus and sulfur, S 2 minus, so then I added another FE 2 plus and another S 2 minus, and I got FES, because they cancel each other out.
Yep. So the charges are the same, so they cancel out and you get FES. Did anyone try the other one that's like more difficult? The other charge of F?
We tried that.
Was it?
Charge 3 plus. The charge is FE3 plus. So we want to balance this one out. FE.
No.
Yeah. It'd be FE2S3. So if I add another FE3 plus here and I add two S2 minuses, what I get is a total negative charge of 6 minus and a total positive charge of 6 plus. Right? So 6 plus 6 minus is 0, which is our goal. So we end up with FE2 S3. So remember, the goal of making our ionic compounds is for the overall charge to be 0. Which is why we talk about the crisscross method. You can also use the crisscross method here, but I just want you guys to see how we stack those ions. Cool. So, this next part, Model 2, I'm going to let you guys try your own, or rather with your partner. Alright, so you guys will be at level 2, working on this. And you're going to stop after Model 2, so don't go on to Model 3. What you don't finish is going to be homework, so whatever you can get done, get done. Work as diligently as you can, that way you can have an easy night. Start quarter 2 off strong. Alright, get to work. Still gotta do it. Put the ions together. So it's the bonding rate that negative. So think about it like magnet.
Yeah, I think he counted it.
I would be ignorant with
Oh yeah. 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 No, if we were just letting the groups and having these put together on it, totally agree with that. So first we'll circle the symbols for compound. So for metal. What do you notice about that? Yeah, fine. Yeah, so if this is what trigon does, that the metal is always yeah, so an ionic compound is always true. Like we talked about covalent compounds earlier, those are different. That's what people notice if they're not metals and metals or just non-metals. So with this one, you see that there's metal and non-metal, you know that it's a right?
And that's what everybody gave.
So take phosphide.
Like, everybody said it.
I know, that's why I said.
Everybody said it. That's why I said
So there's three things, there's two phosphide. It's like reverse cross. So like, you know how we cross to find it? You like uncross to like figure out what the charge is.
So I just had to write that.
What is that three?
these are still, we're not going about like, even though I was thinking that's like.
Okay.
This is how many explain the charge of three things. So that's so what is the charge?
I feel like it's a harder one. It's like
So, but from here, it's actually why, because, okay.
Because like when they did it with this one, that's how I was doing. I was just following because I did it internationally.
I want you to get harder than you currently are. So why don't you start with the green as well? Yeah.
Wait, is it okay? Do I, wait, did I do that for all of these?
Yep.
Easy version.
So go back through the circle and ask you to circle the metals.
This is the first part.
Yep. I have some big ones.
Just kind of also, we say no. So this is basically a trick question.
Yeah, it's like, I feel like these aren't supposed to be trick questions, they're just like, is there? Yeah.
Alright, so that's obviously. If you were back here, you would
Which elements?
Like you've noticed that. The reason for that is because they always, like these always have the same charge. So the ratio is going to be the same, right? Because you know what charge. Not for these ones. That's for covalent charge, this is covalent. That's there we go.
Mr. Ben, is there any reason why you just?
because they won't fix it.
The charge is
Yeah. Well, these are. But yeah, yeah, keep your
Oh, yeah. What we used to do.
Because they don't charge the same. Like for the transition highlights.
So this is earlier for them?
You specify. Well, I mean, the idea is that you only have one possible charge for each of those elements, right? It's either 2 minus always on oxygen or 2 plus always on calcium. So as long as you tell them like which one it is, there's only one possible ratio. So you can even specify. Like, in covalent compound, it's like this one kind of like, they don't have much charge or anything. You have like 6 of this, like 8 of another thing. But in ionic, it's like this has this charge, this has this charge. The thing is about the ones we're talking about right now, these the ionic compounds with only one positive charge, it's always going to be the same charge. So when we talk about transition metal stuff, that's at different charges, then you have to specify what the charge is. Yeah, one second. Only one ratio is possible, given that you have one possible charge of each one. I'll be there.
Oh, man.
Which is math. Those are model 2.
Oh, yeah, I have it. Math.
Oh, it's the
They were working group.
Oh, I'm smart. Oh my God.
Where'd you go? Yeah, okay, what's going on? The thing is, you have a chart, right? For these ones, you only have one on the chart. So you assume a certain ratio based on the chart that you have, right? If you talk about transition metals, that's check. So you have to specify what the chart is. Then you got to balance them. And covalent compounds, you don't have charges to balance, so you got to do like dioxide. This one shows like, well, there's only going to be 3 of these, 3 of this. So I have to specify.
So there's no such thing as
Yeah. You won't put 0 because yeah, I get what you're saying. Like you have like 2 or something. But that's for covalent. For ionic, you always just have to know how many there are based on the charges and what ratio you have.
First of all, I know how to work math.
Yeah, so like the number that we use for the budget that we
have like all
Alright, y'all. Alright, y'all. It's time to do the exit ticket. Y'all been working real hard, very proud of you all. But it's time for class to close. Go back to your seats if you have moved. Work on the exit ticket. It's gonna look basically the same thing as your due now. But this time, we've gone over what to do again, so you should know what you're doing. Alright, so remember, exit ticket is at a level 0.
Use your rules that you like.
So those usually be subsources, right? You know, yeah, basically you have an ionic compound. You can put the diagram and know how many they are phase
Oh yes. Oh, don't say that you're not pretty for a kind girl, this and that. Like, you ever see that when I show? Wait, really?
What you mean? They're in my bag right now. And they, matter of fact, chocolate's in my bag right now. Yeah, we don't know what shit would be. You used to be giving me y'all.
Yeah, I do now. All right. Just a reminder, everyone, finishing the packet. The packet is your homework. I want it turned into the folder tomorrow morning. And hand me your exit tickets on the way out.
That is.
Alright, everybody have a good day. Go get Alright, have a great day, everyone. Finish your homework. Take a nap.
No homework. No homework, right?
There's packets of homework.
Y'all couldn't even give us a little break. Right.
As soon as everybody started.
We're hitting the ground running. We're gonna
Start already breaking my whole grade.
Yeah.
Other people are fine.